Hello everybody. So this is another question we have is Q2 in the contest 164 two-letter card game. So let's try to understand the question. Very first, we have given a deck of cards represented by a string array that is called cards. So each card displays two English letter, lowercase letter we can say, lowercase letters, and you are also given a letter X. X can be anything, any English letter. You play a game with the following rules. What are the rules are there? Start with 0 points. Means when we are starting playing the game, your points is 0. On each turn, you must find two compatible cards from the deck that both contains letter X in any position. Understand? Then you have to remove the pair of cards and earn 1 point. The game ends when you can no longer find a pair of compatible cards. At that time, you have to return the maximum number of points you can gain from the optimal play. And then two cards are compatible if the string differs in exactly one position. Right? What is the rule is there? So when you play the game, very first position, your points is 0, that is fine. In each turn, you have to find the two compatible cards. Okay? And both contains letter X in any position. So you will remove the pair of cards by earning 1 point, and the game ends when you can no longer find the pair of the compatible cards, and you have to return the maximum number of points you can gain by the optimal play. And what are the two compatible cards? If the string differs in exactly one position. So if you'll say cards, we have AA, AB, BA, AC. So in this case, we have X is A, right? So we have to find the pairs. In the very first turn, it is saying that you have to select and remove the card AB and AC. So we have AB, let's suppose, and we have AC is there. What is common is there? A is common here, right? Which are compatible because they differ at only one index 1, right? Means we have AB and here we have AC. So here is B and here is C, right? That is why it at index 1 it's differ. Similarly, on the second turn, you have to select and remove the card AA and BA, which are compatible because they differ at only one index, that is called 0. So if we'll take AA and here we'll take BA, right? Means if you see the very first A letter is differs. So that is why they are getting the chances at index 1 and index 0 that differs, and it is a compatible pairs, we can say that, right? Because two cards are compatible only if they have exactly one position, at the same position it's differ, right? So you understand the problem, right? That is why it is saying further there is no more, so total score is 2. I hope you understand. Let's understand how to write the code. So let's understand how to implement this problem, right? Very first, try to understand that in very first, like what does the compatibility means here? Okay, so we know that there will be a card, and from the card we'll get two cards, right? Can we say that the cards card A and card B, we can say that, right? So if two cards are compatible, means both contains the given digit, you can say the letter is X, right? And so like this case we can say, so if you say we have two cards, we have, right, means we are taking the character we are checking, right? So both contains the what X, so they differ in exactly one position, that's fine, right? So the effective if effectively we can say each card must share at least one letter with the X in the same spot, right? So what we will do, we'll categorize the cards, right? How we will do that? Let's understand. Very first, we want to count the X, right, for the card A, and then we'll count for the B similarly, right, if they are there or not. So what we will do, we'll take the for the we know that the value can be anything, so we'll take the indices like this for A to Z, right? We know that the character letters will be A to Z, and from A to Z the indices could be 0 to 9. and for that we'll take two arrays A and B. Okay, and we'll consider that some count will be there, right? Some characters will be there, and we'll increase it. Okay, when we'll find it, let's suppose very first we'll take the cards and we'll get the characters. We'll check both character contains the X. So if any card that contains, let's suppose X is nothing but A, let's suppose, right? Any card contains A, that will fall into the out of the three categories, right? So if it is gain the categories means both contains, so we'll say okay, just increase plus plus. So as we say, we have taken outside, we'll increase the plus plus. Okay, otherwise we'll check if it is in the A or if it in the B, so we'll increase its we can say at the position in the respective array, we can say, right, for the card A and for the card B. So here the purpose is to categorize the card, right? And we'll check the characters. Both character contains either of these three we can say categories. So these three are the categories. When both is in the same category, means both letters are X, right? Let's suppose example AA. Okay, so this card can pair with many others because changing one of its position can gives you another valid card, right? When we talk about when X is there or not in the A, right? If it is not in the A, means X is the first position and the second character is anything, it's not X, right? So in that case, let's suppose we'll say AB, AC, right? We can say that. Okay, when we talk about the else condition, right, where we'll say X is the second position and the first character is not equal to X. Let's suppose for BA and CA, right? So now this way we will categorize the cards. Okay, now now what we will do? So okay, so very first what we will do, we'll try to find the pairs that is coming from A, right? So A with A, if it is compatible with their second character that differs. Let's suppose we'll talk about the AB and AC, both start at A, right? Like that we'll check. So for that we'll take a loop, right? And we'll similarly we'll find the cases, sorry. Okay, so we'll try to find the cases where how many pairs we have, that we will find. Let's suppose for AA and there will be BB, right? Like that we will find the character, right? If let's suppose in the BB in the case, let's suppose we have BA or CA, right? We have, right? So we'll say B with B and this is A with A. There can be other possibility. We can say that it is possibility that there will be C with A, means always compatible because AA and AB differs in both position, right? So that we can say. Okay, so these are the things that we need to do here. Okay, then the topic comes with the greedy. Okay, so when we'll do the greedy type, right, at that time we'll check the why we are doing that, because why not just the pair everything greedily, it increases, right? If it increases, we can take all those values, right? Let's suppose we have example AA, we have AB, we have, right? Like that we have. Let me tell you how. So let's try to understand. Okay, very first, let's suppose the example was given with AA we have given, AB we have given, B was given, and CAB was given, right? AC was there, right? Like that we have given. You can take another values also, just for example. Okay, let's suppose this is what we have given in the array. Okay, and the X, let's suppose, is A. So if we want to find the greedy, right? So greedy could give a pair. Let's suppose we'll talk about the A, and we'll take another character is AB, right? We can take that. So if we'll take that, then let's suppose we have character is BA and AC. Can we say that? So it is not compatible, right? First and the second, can we say it is compatible or not? It is not compatible, right? Because here BA we have and here we have AC. But in this case, we can say, yeah, it's fine. But in this case, it will not be pair, because in this case, we are getting what? AA pair, right? And that we can say yes. Then if we talk about, if we want to make any other combinations, the optimal combinations will be what? Let's suppose we'll say, no, we'll make another condition that we have AB and AC. So this will also give you AA combinations, right? If we'll take we will take AA and then we will take a BA, right? We can say that. In this case, we are getting CB pair, right? So only in this case, the orders matters. So we need to have a strategy that will take care of globally, right? Globally, it should be good, not the only the local things, right? We cannot take. If you'll take the locally greedy, that will not work in this case. And for that, you have to use these conditions, right? We clean it, okay? So what you need to do, we have to greedily you have to check the conditions, okay? Very first, you know the conditions we have. This is the operations you have to do, right? Selling value, floor value, you have to take this, and then you have to use the combinations you have to find, right? Because everything you have here in the conditions candidate, right? And then we'll find the score at the all the times. What we need to do, we have to check the minimum the count we will take, and what is coming from the AB minus 2 into AB means you have to take remaining A, remaining B after how many integral pairs we have. And for that we need to do what, we have to find the base score and you will get the answer here, okay? Actually what we are doing here, let's suppose we already find the total A and total B we have find, right? Means total A is nothing but the number of A cards, right? And total B is nothing but number of B cards, right? And there will be a C card, number of C cards also, right? For the C. So what we need to do, let's try to understand the total score, how we will find it. So if you want to find the total score, let's suppose call total score is S, right? To find that, we know we have to find what? S is nothing but what? We can say PA plus PB. It's an integral part, right? Integral internal pairs we can say, where we have the P is a maximum possible AA pairs, right? And PB is a maximum possible BB pairs. Then we can say that we'll say S plus we'll take the mean of what? Total A plus total B, right? And we'll do minus 2S. This is what we need to do, because 2S is what? 2S is the I spent 2S card from A or B, right? And the leftover is what? We can say our leftover. So we'll say total A plus total B and we'll do minus 2S. So this part is nothing but the leftover. Okay, so each leftover we can try to pair with the C cards. Okay, so I'll try to put this code into comment box, and I'll also do the deep dive session where I'll show you with the slides so you will understand clearly. Okay, so that's all. Thank you.